Hey guys, Mike from Missouri, back on the 1840 skid steer rebuild, and it's time to start diving into the hydraulics. I'm waiting on some parts to finish up installing the axles, or the right front axle, because I got a chain that I needed to order. So I decided I would take the next step in getting these hydraulic motors taken apart. This motor is off the right front, and it's got some scoring on this shaft here. It's not terrible, but there's some waviness in it. It's definitely not good. I don't want to run it that way. I'm afraid I'm not going to be able to get this shaft, but that's what we're doing. We're going to see what we can get, what we can't. I went ahead and cleaned this all up in the parts washer. This is a Danfoss. Let's see. I think it's a model. I think that's either a 290 or a Z90. And number 151B20979472. It's hard to make out. But anyway, I think this may be the late style motor. Got a manual over here, and it calls out an early and a late motor, which mainly the difference being is it was a little shuttle valve or spool valve on the side of the early motor, and mine doesn't have that, even though I have an early machine. So maybe these have been swapped out before, I'm not sure. But let's get to taking it apart. We'll see what we can do with it. Now, the first thing the manual says is to set it on in and loosen the rear cap screws. I got a hole in my table here for like a 2-inch Reese receiver hitch. I'm going to set the motor down in that. Okay, these are, let's see, I think 7/8. This probably won't be powerful enough to take this loose, but we're going to try. Kind of what I figured. I do want to say that I've never taken any of these apart before. I don't have experience. However, I'm pretty mechanically inclined, but I'm not an expert on these. It's probably not great. Get the O-ring out of here. It looks very flat. Yeah, that's toast. It almost wants to crack by bending it. Okay, this is the end cap. It says you're supposed to lift this piece out. Okay. There. There's a wave washer down in there. Wow. That's pretty crazy. It almost sticks together. It's so perfectly machined. Doesn't look like there's anything wrong with it. That's good. Yeah. All right. Set this stuff aside. Set this aside. All right, I'll get back on this main housing. Manual shows removing this outer ring. It looks like it's part of the case. I'm going to try to mark these rollers just to it's not going to work very well. Right, I'm going to clean that off better. Okay, start number 1 up here by the case drain. 1, 2, okay, I was misinterpreting this wrong. It's not this inner ring, it's this whole section here. It's supposed to come up. There we go. Yep. It's scary. I don't like this at all. All right, I got the whole piece off and set aside. Must be the, no, it's not the main dry shaft. You can see where the rollers sit, but you can't feel anything. Let's take this out. Shows removing these bolts. They call this the seal carrier. That is one hard seal. Maybe it's supposed to be that way because I can't even flex it. Looks like there may be that's what I was concerned about. Let me show you that seal area. A little bit of a wear ring on there. Not sure how deep that is just yet. But, man, I've never felt a seal that. That is hard like steel almost. And then it's showing, so I got the seal carrier up. Move the O-ring, press out the shaft assembly out of the housing only. If the output shaft is to be replaced, replace the seal. All right, let's take a look at doing that. I'm just going to use an old pen. And I need to raise that up. Center this up, make sure I'm not covering the lower bearing. Okay. Hold the shaft from the bottom. Jeez. All right, it's out. Let's take a closer look at that on the bench. Well, looking at these parts, and it appears this has got 2 tapered roller bearings on each side. And then it looks like a spanner nut that's been staked, probably to adjust the preload. And it doesn't say anything about disassembling this. So I would pretty much guess that you're supposed to buy this as one piece. That looks about like a, I don't know, $500 part at least. And the housing, you can see where the 2 bearings were sitting in the, they were sitting there and there. It's hard to see on camera. And then it looked like the bearing race bottomed out on this ledge down in here. And it just sticks through the end. But yeah, it's pretty cool how that's put together. I've never been, like I said, I've never been into one of these at all. I know at a minimum it would need the O-rings, the seal that goes in here, this seal surface, see if we can clean that up. But I really need to do something with the end of this. So I'm going to see if I can find that part. If not, I'm going to have to think outside the box for some other solution. Oh guys, it's the following day and I got some news on the part situation on this hydraulic motor. I was able to source the sealing kit. Unfortunately not through Danfoss. There's an 8-week lead time. But I was able to get what they claim to be a USA made equivalent for $55 a motor. So that should be coming in a few days. But not as good of a story on the shaft damage. On the shaft, I've been taking some measurements on it. You can get this new still for $1,200. And I've had a few people say they had used motors they'd sell me. The more I looked into it, I think I'm going to repair this. And I have some parts coming for that, so I won't get into the details right now, but you'll see later in the video what my plans are for that shaft. But in the meantime, I got some cleaning to do on these parts. Right now in the ultrasonic cleaner, I got one of the, I think it's the back case for the that motor. get it cleaned up. So I'm just gonna spend some time cleaning all these parts up separately, get them ready for reassembly. So this piece is the front flange of the motor. So this bolts into the chain case and the shaft comes out here. And this, I really, I can barely feel. It looks like it's really worn, but it really isn't. But I need to clean this surface rust off around here carefully. This is raised, so I don't have to be as careful with getting into there because it kind of, you have to get over this hump. But all these motor sections seem to have this same layer of surface rust where I guess moisture's gotten between the case halves because the seal is on the inside. And I don't want it to cause an issue with motor cases sealing going back together. This is the end cap of the motor, well, not of the motor, but of the side of the chain case that supports the end of the motor shaft, the part that's scored. The needle bearing is likely damaged due to the shaft scoring. So this part needs cleaned up. We need to get this needle bearing pressed out of there. Also got another one of those coming. I think we can press from the opposite side if we get this cap out of here. Alright, so I got a game plan. There's actually multiple parts to this. This is this kind of outside Heim joint bearing. And then there's the needle bearing. And then on each side of the needle bearing are these thick washers that are pressed in. I really don't, and it's on both sides. I don't know if this is spin all the way around, but so that one of those washers is on the back side too. And I don't want to really try to push the washer and needle bearing all the way through. So I want to find something small enough to go inside of the washer, but yet still hit the rollers of the needle bearing and try to push it out. I have this socket here. I don't really like to use sockets, but this is the only thing I can find short of turning something on the lathe that clears the washer but yet engages into the rollers. So I'm going to try this. Hopefully I don't tear up my socket. See what happens. All right, get the socket down in there, past the washer. Yep, okay. There's that washer I was telling you. Coming. All right. No problem at all. I got lights you guys can actually see in there. So the washers, another one of these washers, fairly thick, is down in there still. It's flush with the end of that ball. And then the needle bearing. So when we get the new bearing, of course we'll clean this all up, we'll press that in, pressing it under flush just enough to get this washer started, and then we'll press that flush and we should be good to go. I got this piece out of the ultrasonic cleaner and turned out pretty good. I want to get the O-rings changed on these fittings. Instead of buying them piece by piece through case, I bought a set of these hydraulic O-ring boss kits from Amazon. So it has all the dash sizes of hydraulic fittings. So I'm going to mark the center line of where these fittings line up to so I can put them back at the right angle. Yeah, I kind of figured that. All right, I'm going to put this in my vise with the copper jaws on it. That's O-ring boss fittings. They take a special size O-ring. Get these off of here. These aren't too bad. They're a little bit deformed. Little stiff. So right on the case parts thing, it says it takes a dash 912 right on this kit. Let's see, dash 912 should be these right here. There we go. Okay. And I'll just wipe the seating surface clean. That one's good. Messed up on that deal.
Nope. Get this one lined up first. Right there. Alright, now we can do this one again. Right there. Socket. That's good. I'll have to do a little bit more on that one. That's good. Alright. Got that done now.
I'm going to go ahead and do this. This is the case drain for the hydraulic motor. So the main high pressure comes in and out of these to drive the motor, and then any fluid that seeps past the rotating mechanism goes kind of on the outside, and so you don't pressurize the case and blow out the seal. There's a case drain, and that basically returns it back to the hydraulic reservoir. So that's the point of that. And I just forgot to mark where I was. I'll go back in the video and take a look. This fitting looks like it was replaced or something recently. Manual says it is a dash 912, but the goal with doing restorations is always change every O-ring and seal. Okay, -912 out of the kit. Go. Okay, this is kind of the nerve-wracking part. I do have it all marked, and I do have it etched into the case on the side of where all these go. The tolerances on this is crazy. Get your look on the side there with the light. See, I got it etched into the paint right here. 1, 2, 9. I know the ultrasonic cleaners works on principle of cavitation. It probably wouldn't hurt this at all, but I don't think I'm going to clean the machine, critical machine parts in it. That's probably being ridiculous. But I'm going to hand clean them, I believe. I think it's the safest. All right, so I'm making gaskets for these end plates. You can buy these from Case. Again, it's like 30 some bucks a piece. I bought this gasket paper for $15, and I can use it for some other things. So what I did was I just took bottom of a paint can, traced it, and cut this out. It fits here. And then now I'm going to do what's called tapping the gasket out, and I'll show you how that works. You can see it's leaving the impression of where the gasket needs cut at. And it even works for the bolt holes, actually. It works better on thinner paper, but it still works on this. Now this paper is the same thickness that Case specifies. I think it's 1.5 millimeters, or roughly 60 thousandths. This is 1/16 or 60 thousandths paper. So now I know where to cut my holes and cut the outside. Our completed gasket. Fits perfect. Well, it's been a few days and I got a part in. As I mentioned, this shaft is scored and I can't find a replacement for a reasonable amount of money. This is that needle bearing that I pressed out of these, let's see, end caps over here. So I am going to show you what my plan is to repair this. Got this Koyo part number IR-1216. And this is internal race for needle bearing. That's its intended purpose. And it is exactly the size I need. It is 1-inch OD. And it's 3/4 inch ID by just over 1 inch long. So you can see the previous wear pattern goes to here. This mark is where the race was rubbing. So it clears the surface contact area just fine. So we'll turn this shaft down to just over 3/4 of an inch and press this on. And that's how I'm going to repair it. So on the back side of the shaft is a locking nut that adjusts the preload of this bearing assembly. It's staked. I'm pretty sure it's going to be a good enough surface to clamp down on with my lathe chuck. And obviously you can't clamp on this surface. If that doesn't work, I'm going to have to press this bearing off, but I've kind of played with this in here a little bit and it seems like it's going to work because I have it set up pretty close to where I need to be with it. And I'll show you how to dial this in. We need to dial this shaft in so it's perfect, so when we turn this we don't have any run out. Put my dial indicator. Put my dial indicator on. So you can see I have about 20 thousandths of run out, and we're gonna get that dialed in. So that's a high area right there. Tighten that. A high. We're down to about 4. It's still way too much for what we're doing. About 3. It's about half. A little bit more in this one. That should be good. That's less than, that's probably a few tenths right there. That's as good as I can get it. I'll go and check this end. Looks like we're probably about a 1/2 thousandths, which I'm going to call good enough. I realize not everyone's going to have access to a lathe, but what you could do is you could order that part number, bring this shaft to some local machinist or company in your area and ask them to do this. I don't know what it would cost, probably a few $100, but it's definitely an option. So I got a new carbide cutter in here at the CNMG on this this tool post holder here, and I'm going to touch off and start laying this out to where I need to be. This is 1 inch 10 thousandths wide. All right, I actually had to switch the dead center to a live center. It started getting hot a lot faster than I anticipated. At that RPM, it just wasn't going to work. So I still have less than 1/2 thousandths run out. I'm gonna go ahead and make a pass here and try to get this shoulder where I need it to be. I need to come a little bit more over. It's hard, very hard. All right, I got you on the back side of the lathe, and I had to completely change what I was doing. One, I had to slow the lathe way down. I was running 1,000, it was burning up the bit because this is so hard. I backed it down to 600, and I changed to a new bit, and now I'm actually able to cut instead of build so much heat. I got about 50 thousandths left to cut off yet, so it's working out a lot better for me. All right, I just took the final pass and went over it with some sandpaper to smooth it out. And I'm 0.7502, so 0.2 of a thousandths over. That should be pretty good fit for this. I might put some bearing lock retainer on there, so let's get it taken out and press it on. All right, I got this sitting in arbor press here. This is a 3-ton Famco. I'm gonna do an arbor press because it gives me a better feeling of just how tight it's going on there. I got some Loctite retaining compound. I cleaned both ends and inside the bushing with alcohol. And I'm gonna just get some of this on there. Maybe, yep. It's probably unnecessary, but just a little extra insurance. Okay. Now there's a little relief here. I got a little bit of a radius on the shaft. It's not quite as aggressive as the relief, which should allow it to go all the way up to the shoulder. Now I don't anticipate this being too terribly hard. It's down on there, but not all the way. I keep hitting my camera. All right. Got a little gap here. I'm gonna see if I can get that down the rest of the way. I forgot to hit the record button. I just put a socket in here, brought it down that little extra bit. I think the end of the shaft may be hanging out 5 thousandths maybe, but it's not gonna matter a thing at all. Really, really happy with that. That's gonna be a long-lasting repair. Well, finally got some time to really dive into this motor. I've been cleaning all the parts up. Got this main bore where it holds all of the rollers cleaned up. I'm not sure what these are called, but they're the plates that control where the oil is injected into, which cavity. They look to be in really good shape. I'm going to do some further measuring on them. But I just got this surface plate. Purchased it from actually on Amazon. It's an import plate. It is a grade A plate, but it seems to be really, really accurate for the money. But I got my dial indicator. I'm sorry, this is actually called a test indicator, and got it on checking the surface where it looks like this is worn, but you can't feel any of this. And I was concerned if it was serviceable or not. And I just want to show you when I sweep this what it does. I don't know if you can see the dial, but really it doesn't do anything, which tells me it isn't worn really at all. You can still see some of the scratches in it from when they cleaned it off after machining, but there's no measurable wear. This is a 0.5 thousandths indicator. And just so you can believe me as far as whether I got this all set up correctly, watch what happens when I run it up on a piece of paper. Get it close enough to see. It picks that up real easy. So you go from what looks worn, nowhere, no measurable wear. So I'm not going to do anything to this. You can't feel it. It should be good enough. I was looking at this piece. It's another one of those fluid direction pieces. I got some very significant deterioration of O-ring here. So it's a good thing I took these apart. Like I said, I'm not really trying to rebuild them. I would call it more of a reseal. Because there was no performance issues that I could find when I was driving it. And you can't feel any of that. It's just polished from where it's riding. I was able to source a USA-made seal kit from Fluid Power Shop. There's a number, DAN 151B0113, and this is an OMT series motor. I've noticed some interesting things here in that some parts in this kit that I don't remember taking out of the motor, and I think it's because they weren't in the motor. One being this seal, and looking at the parts diagram, I confirmed I definitely have a late style motor. It shows the housing that I'm working on here, and then this little cup seal, which is this red seal, goes in before the shaft that we fixed. And it even says install the seal in the housing and then press the output shaft in. So I'm pretty confident. I went over and looked on the press to make sure I didn't drop it, that it never had it. So this drops in here. There's a little recess that fits it. And then it looks like it rides on there. Let me see. It's kind of an odd. Yep. There's almost a little wear mark there. It looks like it had one at one point, but I can't find this anywhere, and I know I didn't take it out, so it either fell out or didn't have it. So we'll get that in there. The other thing I noticed is this, what they call, it looks like the manual is calling it a wiper. That wasn't installed either. So I believe that goes on the seal plate. I'll show you here in a minute. But I washed this out multiple times, blew it off, and then I went and sprayed it down with mineral spirits, the whole thing. Sprayed the bearings, moved a bunch of fluid through the bearings and spun it, blew it out, did that multiple times. So these are as clean as I can get them. I'm going to go on the press and press that in. Being this is a pretty critical surface, I'm going to put some copper in between that and the press plates so I don't mar the surface. Okay, got the copper sitting there. Space those out a little more. Oh. I know the proper way would be to not press through the bearings, but I cannot find any driver that would allow me to press on just the cup. It's not terribly hard to press in. And I pressed it out through the bearings, so if there was damage done, it's already done, but I can't feel any roughness to the bearings, so I truly believe it's okay. These are a lot of rollers in there, and it's spreading the load pretty good. I don't think it's a problem. Well, I didn't feel comfortable pressing through the bearing really tight to make sure it was seated all the way, so I took some muffler pipe and slid it and kept cutting it down until it was just the right size to go over it. So I'm going to use that to do the final pressing. All right, well, pretty certain it's all the way in. It's very hard to turn. I've been tapping on it, trying to relieve it. I think it's just how it is once the bearings get kind of crushed in. But if you put it in the vise, you know, you're turning a much bigger object and it turns smooth, although it's under a fair amount of tension. Hope that's normal. Seems to be a little tighter than I'd like, but we're going to roll with it. It looks like the next step is to take the seal plate, which I got all cleaned up right here, and put a new seal in it. And we got a new seal here. Okay, we're going to install the seal lip up into this seal plate. It looks like this pipe will work pretty good for the driver. All right, I got a different piece down here that fits the diameter better. Well, that looks to be all the way in. All right, got the seal installed, and I got flipped this upside down. There's a seal wiper. This part was missing. Definitely did not press one of these out. All right, so I've been flushing this bearing with transmission fluid. I turned it upside down, pumped oil through here while spinning it, and I also did it the other way. Well, good news is it turns pretty nice and free now once it got some lubrication in it. And I ran about a half a quart through it while rotating it, just in case I got any debris in that bearing while pressing it. Now I'm ready to install this seal plate. I'm going to blow it off one last time. Take some of this fluid and put on the seal. And the O-ring for that's right here. Use some Vaseline to hold the O-ring in place. Okay. It's down in the groove. Wipe the extra Vaseline off. Definitely don't want to roll that seal. It's a pretty stiff steel. There we go. All right. Okay, so looks like I'm missing a bolt. We'll put the 5 in that I have. 100. There it is, minus one missing bolt. Well, as you saw, I put in the video that I put this lip or wiper seal on backwards, so I didn't realize that until laying in bed the following night. I'm going to zip this back off. I ordered another seal kit. It was just the easiest way to get a new seal because I doubt I'm going to get that out of there without messing it up. Found the missing bolt. Okay. Well, surprisingly, looks like I didn't hurt it at all. Try to tap that in. That's the correct way. Lip up. Main seal goes lip towards the internal bearing on the pump. There, we can get this put back on now. Okay, finally starting to get close to start putting the hydraulic section of the motor back together. Okay, next step says to fill the inside of this with clean oil up to the top of those splines. Okay, there we go. All right, next step is to put the spline shaft down in. Call this the stator. It goes on next. Got a new O-ring. All right, there's a hole here. It's got to line up with that hole there. All right, just like that. All right, next step is to install the rollers. These will go the markings down as my numbers are upside down. So I know that those need to go numbers down. I'm going to take number 1, wipe it off, and then blow it off. Make sure I don't have any lint on it. And number 1 is marked right here. There we go. I'll keep doing that all the way around. All right, next step is install the rotor. Yeah, it's tight. Okay. I double check the O-ring. Oh. All right, that all looks good. All right, now I guess into some of the timing of these plates on top. It says to make a reference mark between 2 teeth. So we'll call that our reference mark. And then we're supposed to make a reference mark between 2 lobes on the rotor. Like that. Okay, and then install the small shaft so that they're aligned. Okay. See that they're in alignment. Okay, next step, put a new O-ring on this part. They're calling this the stator. Now, I think this is actually the manifold. There's a little pin over here. It needs to be engaged into that hole. I'm going to put a little bit of, well, I guess I don't need to put a little bit of oil. That's why we dumped it down in there before we installed everything. So I'm going to turn this upside down and get that aligned. Okay. All right, this is the critical timing part. Again, I've never done this, but I'm following the manual. Manual says to align one of these holes with that mark. And when you do that, it won't slide on the shaft. So you can see this outer hole here is aligned to that mark. The splines won't line up, and then you're supposed to rotate it counterclockwise until they fall onto the spline. There we go. So that's supposed to be timed correctly. All right, now we need to focus on the end cap. There's a wave spring that goes in. And then this piece goes in after that. It has two O-rings that need installed. This is the O-rings that were disintegrated when we took it apart. That one. There we go. So there's both the O-rings. Got our wave spring. And we'll put some petroleum jelly on these O-rings. And then this roll pin aligns with the hole in the cover. Not sure if it's. Doesn't feel like it's going all the way down. There we go. All right, they call this the spacer. You're supposed to put petroleum jelly on it. Just stick down in there. It won't go crazy. Okay, now we're ready to install this. And you got the two supply lines, supposed to align it with the case drain. Oh, do one thing. There's an O-ring here. I want it to lubricate the case where the O-ring slides over. Go. It says you're supposed to pull it down with the cap screws, so oh, something doesn't look right to me. I don't know if it's normal to be able to see gaps in there. I need to go check the other motor. Now, looking at the other motor, that's normal. Just seems a little odd. Well, you guys missed it, but I put air pressure in here. Try to get the motor to spin, which it did. Blue fluid all over the ground, up on the door. I just got done spraying some like brake clean all over the floor and wiping it up. It still needs to evaporate, but what a mess all over here. Sometimes I don't use my brain. All right, I'm gonna jump right on in on the second motor. It's pretty nasty. A lot of form in place gasket that they were trying to, I don't know what they were trying to do, and just some residue, dust, dirt. I'm gonna bring it over to the parts washer and get it cleaned up. Now the good news on this one, the shaft is not damaged, so we don't need to do anything there. But I always like to get the parts relatively clean before I start taking them apart. I kind of had to learn the hard way on a few other projects. You just can't see the condition of the parts real well, or how they come apart is good if you don't spend some time cleaning them up first. Well, let's dive into this one. Okay, I'm going to go ahead and mark these also, just like I did on the other one. On the other motor, this manifold pulled right out of there, but remember the O-rings on that one was kind of messed up. The repair manual says to use a blind hole puller, which is what this thing is. So, let's see, yeah, it comes right out of there with that. And O-rings look in good shape on this one. Well, they're going to need to be replaced, but they're not crumbling apart like the other one was. Again, I'm going to scrape all these surfaces clear of rust. Well, I found a little bit of a problem on this second motor. At least it was different than the first one I put together. The first one, this center collar was completely snug. And I noticed that just in general, this bearing seemed looser. Now the bearing feels smooth. It doesn't look like the stake has come loose or anything. But I talked to a case service trainer for many years. He said he took these motors apart and this is supposed to be snug. And his suggestion was to just tighten this up a little bit and make it similar to the other. So that's what we're going to try to do here. So I got a universal spanner wrench. I already have this adjusted. Tap it into the holes. Baby's tight. I think I did move it a little bit. All right, crank down on the vise some more. Here we go. Ooh. Definitely moved it. Oh, man. Should probably unstake that a little bit. I think that's what's holding me up. It's coming up against the edge a little bit here. Man, not sure if it changed anything or not. I can still work on this off camera a little bit. Well, there really isn't any tightening of this nut because there's a shoulder on it, which only allows the bearing to get so tight. Okay, well, since there's a lip here, I couldn't get the nut any tighter. And I needed to get this bearing down a little bit. I took my lathe and I took off about 1/1000th where that lip is to let the whole nut come down a little bit more into this race to get this clearance. I took the bearings off and they look perfect. No reason to replace them. So I'm gonna fit this, and if it's not enough, I'll put it back in the lathe and cut a little bit more. All right, got the shaft all put back in the housing. Got the nut. I turned that little section out on the inside, 1/1000th off. Was able to snug the nut down, and it just tightened that center spacer up perfectly. Restaked it. Threw this in the freezer and this in the oven, and it dropped in, and I have a great feeling on the bearing now. Real happy with that. I'm gonna continue with my reassembly. Not gonna show much of it because you saw the first motor go back together. Well guys, I finally got this motor wrapped up. Appreciate you watching. This is a long video for me, but it was pretty detailed, and I hope it helps you out if you're resealing or rebuilding one of these Danfoss motors from an 1840 or 45C. Please give me a thumbs up if you liked the video, and we'll see you next time. Appreciate it. Thanks.